Hi, this is Billy Ren, and I would like to discuss service virtualization. This is a two-part series of service virtualization, and now we're gonna be discussing creating a service from scratch. Previously, our application architecture where the channels was actually connecting to the front end application, where the virtual member accounts were were simulating the behavior of the member accounts using service virtualization. Now, on the second part, so we still have the same channels connecting to the front end application, and we have now two services and the member accounts, which is running on the services using the REST architecture or the REST protocol, and now which is the fraud detection, which will be feeding the fraud detection to the application health insurance app, which is not yet existent. So we're gonna be building the fraud detection REST API using service virtualization. Now let's start the demo. Let's open ADM products folder. Now on ADM products folder, we have service virtualization installed, and with different editions of service virtualization, it comes with a package of all the SV demos and the supported protocols. So even with the community edition, you get to have all this package, and in this package, we can actually have guidance on how to use service virtualization. And in this demo, we're gonna be using REST and fraud claiming process fraud REST demo. And within this folder, we have the real service that we're gonna be running the application at, and we have the virtual service that we're going to be um, running the service at. I'm going to come back to you later to show you the services which will be running in this batch file. And what else is included is a guidance, a README file on how to use this virtualization demo project. Now, upon loading of this README file PDF, so you can see introduction and application topology, how it works. So we have the GUI client, the claiming process service, and the virtual service for fraud detection, the system dependencies, which is the members accounts, and the fraud detection, which we are going to create, which is currently unavailable. So as you read further, you can have more information on the JSON, the output data um, on this README file. Now let's start SV. Now on this demo, we're using version 5.1.1. So once you probably install, this may be not the latest version already of service virtualization, but most likely the contents of this demo is still going to work on backwards compatibility. Now upon loading of service virtualization, so let's create a new project, new virtualization project. Let's change the name. So let's say change the title of the project. So let's say service virtualization, creating REST from scratch. From scratch. Let's say. So okay, I think I spelled it right. Press save. Press create. Now let's create the service. Let's right click, add virtual service. Now on the previous demo, we didn't have the objects mapped, um, and we actually virtualized the existing service, REST API. And now because we're actually building the API from scratch, its dependency is to be able to map the correct objects, which will be consumed by the API. I mean the front end application, which will be consuming the API. So the correct objects should be mapped properly. So now we're gonna grab that, which is already available for us. So we have it on JSON format, and this is generated from Swagger itself. So I'm gonna add that. Press next. Now let's change the agent, which we are going to be using. So as explained from the first part of the series, we have we can choose from three on the REST protocol, and it can be a HTTP gateway or service virtualization can act as a proxy under HTTP or HTTPS, or and we can have an HTTPS gateway. And right now we're going to be using HTTP gateway at this demo. Now let's press save. Let's press virtualize. Now localhost service was successfully virtualized. Now we have a full virtualized API available for virtualization. Now let's go back to the JSON file that we actually mapped. I want to show you um, what's inside of the JSON file. Now I would like to show you what the mapping is like on the JSON objects, which will be mapped on the API. So right here, this is a Swagger generated objects which has been mapped. So it shows from the top the Swagger version, so the title, the host, so the base path. So there's quite a bit of information here, and you can see there's a parent-child um, relationship from responses as well as 200, the description, um, so the property itself, the type, and it may be a string. So all of this is actually detected automatically by service virtualization. Imagine the power of that. So let's go back now. Let's exit. Now, having said that, assuming in a situation that we're building a huge application, it may be a web front end, a desktop application, and while building this desktop or web or mobile application, we're dependent to the APIs. It may be third-party APIs, internal APIs, and we couldn't continue to develop and create this application because of the dependency of the API. Now, by just creating the objects, we can actually use service virtualization and be able to create the API from scratch and continue developing the API who is dependent to another API or maybe a front end application which is dependent to that API. So it can be a different scenario at this stage. Let me continue. So let me run the application itself. Now we have the claim processing service, which is running the health insurance demo client, and we have the members account service, which feeds the members on the health insurance, and we have the fraud detection service, which actually checks and cross verify if there's been a fraud happening within the application. Now let's try and use the application itself. Let's enter the claim. So now, as you can see, it's been approved. The first name Hercule with the social security number. His application is approved. Press next. So now, fraud detection service, which is in action right now. So it's saying that investigated for past offenses, fraud 22% likely. Now we go press next, answer claim. So pending approval above limit. So right now, as you can see, fraud detection is now working. And let's press exit and let's do an answer claim again. And what is going to be its behavior on its absence. Now, as you can see, fraud detection is cannot be found, so it cannot create a claim on its absence. Press next. Now, let's virtualize that and get this application continuously running. Let's open SV. Now on SV. Now this is the home page of SV, and 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 the application itself, the health application, will be listening to the virtual service. As we go to the left on the localhost service, we go to data modules, and we go to localhost data model. Right now we have a single operation on the left, which can be defined into one is to many, and same on the right. It's the learned data and default response or rules can have one is to many relationship as well. So basically, the numbers represent according to priority. So one, which is the learned data, second is the default response, and the learned data is actually preceding the default response. So this can be done interchangeably according to our priorities on the steps. As we go inside of the learned data, it is currently empty, and regarding the request type and the response, if we go inside the default response, so eventually it doesn't have content on the request and at the same time with the response. Now, since we're gonna be running a REST protocol and a REST architecture, the first row is actually symbolizing that if there will be no content and we have a default content, so either for a request or a response, and we can actually manipulate the request and the response from here. And as earlier that I've actually shown, we've uploaded JSON objects that service virtualization will be mapping to. Now, if we go to the columns and we go to change the columns, now you will see that the JSON objects is mapped here directly. Now, if you go to no content on the HTTP request, we can change it to a JSON input. Now, the JSON input, now on the HTTP request, you can actually see the HTTP headers, which are included and declared on the JSON file earlier. So right now in this demo, we're crossing out the headers and the HTTP codes. Now we're going to be opening all the objects which are included in the HTTP request, and let's check everything to be included and be seen on the HTTP request from the type, claim ID onwards. So we're grabbing all the information from the HTTP post request. Now on this HTTP request, as you can see, we have complete the body, I mean the header, and the body itself. Now working on the response. Now the HTTP response, if we go to the JSON output as well, and we have the capability of manipulating the headers and the body. And right now we're not interested with the HTTP status code response, the output parameters, or the headers. So right here, having it, we may be getting back a HTTP 200 or HTTP 404 upon our development of the application or the API. we can fully manipulate and be able to respond properly on our development environment with these objects and information which has been created. And now, because the object has been mapped correctly, we can actually show um, the types which were included and the properties which can be consumed in any type of language. Now, hiding the request tab, now going to the response, we have the full capability of manipulating the headers and the body of the response. So we can actually have the full status code, the content type, and the output parameters. So we may be having a HTTP 200, 404, according to how we manipulate the HTTP status code. And we have the complete body response that we're looking at to be able to continue coding and developing the API dependency or the front end application that we are looking at. So right now, after checking the body response of the REST API that we are creating using service virtualization, let's press OK. Now let's go to view options and functions. So what this means is to be able to simulate whatever the request is actually passed as a request, that we can actually respond correctly within the request of the HTTP request and having the correct HTTP response. As actually shown earlier, since our front end application, which is the health insurance app, is dependent to the fraud detection, so it is mandatory to be able to give a response, otherwise the front end application will fail. So right now, eventually, as a first priority, we're giving no consent to the dependent application. Now we're gonna put the response which we created, which is a JSON output, on top priority instead of having no consent as consuming on the endpoint HTTP response. So we're gonna move the row up. Now, as you can see that we've mapped the properties within the JSON response, but we are still actually giving an empty data. So right now, let's actually put something on the fraud type. Let's go back to the document that we had earlier. So let's go to the README file. Now, upon scrolling, let's find the data for the risk. Now, for the service, the types of fraud on the service output data. So now we're gonna copy unspecific. Copy and use that data in our virtualized API. Let's change it back to its old fraud type. So let's delete what it has right now. Let's paste. Now we have unspecific. So eventually the risk score. So let's put it to 0 right now as a response, as a risk score. And of course, we should have a reference for the response. So ID, I think right now will be the best reference. So we copy the ID, and the claim ID will be unique on each request and response. That's okay. Now, let's go back to the column, because the desired columns that needs to be displayed in the request has not been displayed. So let's go back to the columns, change columns. Let's go back to the request, claim, press OK. Now it is available. Let's go back and get copy from, press OK. So we copy from the claim ID requested. So what it does is the claim ID on the HTTP request will be copied directly on the HTTP response. Now we have actually created the minimum requirements to be able to respond to the health insurance app. So let's press save and let's go back to the main page and let's press simulate. Right. So right now the simulation is not running. Let's go back to the application itself. I'm going to exit on this application which is running. Let's go back to the folder. Now, on the earlier we were running on the real service, and now we're working on the virtualized API. So as we go in, I want to show you what's inside. So right now, we're actually running on two services, and the other is what we've created. Let me show you what we have, and we're running on the Nimbus client 7200 port 7200 and slash demo slash fraud detection. So copying that, so we have this API which is being running on virtualized, and this is the demo accounts API, which is member accounts API, which will be running on a real service, while we're going to be running the fraud detection using service virtualization virtual service. So let's press exit, go back, run the virtual data. Now, as you can see, we only have the members account service running. Let's enter a claim. Now, as you can see, it runs successfully with the absence of the fraud detection API. Now, we were be able to run the application successfully and let the developers actually work continuously with with the virtualized API. Now, let's actually create some scenario that we're gonna be creating some additional rules and different data to be to respond and consumed by the health insurance app. So let's go back to service virtualization. Let's go back to local data model and let's create a new rule. Let's create a new data rule, and let's say it's for oops, let me just change that fraud detection rule. Now let's put that as a top priority on top. Now it's on fraud detection rule. Change the number to its priority. Now it's 1. Okay. Let's go back to the fraud detection. Now let's add the row and let's display it in row detail. Now, so let's actually map it through and manipulate its behavior according to the social security number. So let's say the SSS number is something like what we have right now from Hercule Poirot. Let's copy that. Let's go back and paste it. So let's set as the fraud type. Let's set it as let's say repeated offender, and with the risk score, let's say as 20. So you can see we can now choose it can be a random generator, sequential number generator, or it's actually date time related to, and we can actually manipulate the response accordingly to our liking. So let's actually set right now and give a constant return. Let's say 20. Since we have set earlier, the claim ID will be copying from the HTTP request. Now the response will be responding with the claim ID as the HTTP request. Now let's press close. Since um, this rule is on higher priority than the succeeding learn data and default response, so this will be the uh, first priority response on the HTTP request. Now I'm going to press save. Now let's go back to the home page. I'm going to press stop and restart the simulation. Let's go back to the application itself. Now, because we've copied the SSS number, the social security number of Hercule Poirot, let's do an enter claim. Now, as we actually manipulated, so investigate for past offenses and fraud is 20% likely as we actually answered as the HTTP response to this request. Thank you for watching my channel, and this is the end of the topic of service virtualization.